Right. Hi, Banvata Hamotama. You all welcome to the grade 11 now. Grade 11 English medium maths class today. So now you are moving to the grade 11. So I thought to start the grades 11 syllabus today onwards. But if we have some balance part of 10, however, we will recover that balance part while we are conducting the class. Okay, right. So now this is the year for you. You will have the exams mostly at the end of this year. That means December. So this would be the yours year 2025. Right? In mathematically, it is a nice year 2025, and so you will learn a lot throughout this year. And this would be the last year that you are learning the O level syllabus, and then you move to the A level after this year. Okay, so this is the last year that you are learning maths. Also, sometimes some students, if you do not do A level maths, especially maths, otherwise you will learn maths in the at the last. Okay, right. Get a good move for this year from the beginning, right? So you have at least 12 months, maybe 11 months, 12 months period to cover up the grade 11 syllabus as well as to face the O-level exam, right? එහෙනම් හැමෝටම සුබ වෙන්න කියලා ප්‍රාර්ථනා කරනවා ඊයර් එක තමන්ගේ ඊයර් එක කරගන්න නිව් ඊයර් එකක් වෙන්නේ නිව් වෙන්නේ සහ හැපි වෙන්නේ අපි කරන වැඩ මත ඒ නිසා හැමෝම එක හැපි නිව් ඊයර් එකක් කරගන්න තමන්ගේ අවුරුද්ද කරගන්න මේක හොඳට මහන්සිලා වැඩ කරන්න everyone to be work hard to become as a happy new year 2025 because this is the year you are facing your O-level exam, right? So we completed mostly the grade 10, around 99% of grade 10 syllabus. Nowadays, I think most of you are having term test exams. So you didn't face some students face the paper, but some didn't face the paper. But hands up those who face the 10th third term exam up to now, who faced the exam. Okay, few of you faced, and some are not yet faced, and in northwestern province they started the work exams this week, and maths is on 15th. Some are having the subjects these days, that's why I think some are not attending today. No problem, however, right, I will work hard for you throughout this 11 months as I can. And further, you have to work by yourself because this is the last year and very, very important year in your life, in O level life. Okay. So to increase that one, I have especially designed a tute pack to you also, right, for your grade 11 students. Because you know that although we cover up some theory parts and we did some exercise question only, that is not sufficient, especially for 10, 11 students. So that's why I arrange a tute pack and I have further checked the typesetting and I developed the question itself by myself, most of the question, and I translated some the other medium questions to the English medium and the arranged the tute pack. Okay, so mostly for you, I am planning a tute pack on monthly basis mostly, right? Imagine this tute is finished within this month, then I will arrange the next tute for next month. Once the tute is completed, I arrange the next tute delivery. And further, when you come 2-3 months after this first term, I arrange a revision tute pack separately. So no any additional payment will be taken under the same class fees. You will receive the tutes, even no any delivery charges applied. So you have to take the tute by yourself, right? So I will arrange that revision tute pack at the end of this term for the first term, then second term another revision tute pack apart from these lesson tutes. So because we need to work hard and work more for this O level exam. Okay, and further, you know that for this year facing students, I am doing math class for 5 days, per week, 5 days for this O level students who are facing this March. So we have 5 days class maths, right? So some of you attending some revise and rise class also, they knows that. So that's why we need to work hard. Otherwise, we cannot get a maximum result. So when also you comes to the near to the exams, I arrange such programs to you within the last 3 months at least for you before your exam. We will work 5 days per week for maths, no problem. You can enjoy it nicely and you can enhance the marks. Right. So in the paper class also, we cover up to now 23 papers. So you can, those who didn't deal that paper class, you can also deal with the paper class because we have to do the papers, then only the marks is increased with the practice of the papers. Right. Okay, fine. So that is understanding. Now you know that grade 11 syllabus, we have three terms, right, in grade 11. So grade 10 is the majority, but some grade 10 parts is repeated in grade 11 with the advancement of the grade 10 content, right? For an example, graph question is there in the grade 11 paper, syllabus also, but some advanced graphs there. Okay, then we have the like solids are there, some advanced solids come to the grade 11. And when we have the surface area, but additionally solid surface area comes to the grade 11. Likewise, the probability set is there in grade 10 also, set probability there, but in grade 10 two subset only, but in grade 11 it enhanced to the three subsets. For the probability, the grid line having replacing back events, but here not replacing back event added newly. So likewise, the 10 base is compulsory to have to learn the grade 11. So don't forget 10 now. Some students when moving to another grade, they forget the previous grade. But for maths, never. Huh? You have to have the 10 plus 11, both like a chain, right? If you forget 10, you cannot deal with 11. So that's why we are doing a paper class and paper revisions to recall the grade 10 syllabus. At any time, we have to recall the grade 10 syllabus because all level is designed for 10 and 11 both, right? So normally our class timetable for this year also the same as this, and paper class the same as the Monday, the time period. So at the end of the third term, before you move to the exam, we arrange that the revise and rise for you also separate additional programs near to the O-level exams, the past paper revision, these things will be done. Okay, right. So this is our program. So if any questions, you are allowed to ask. Right. From next day onwards, I give the chance to talk to me myself, to everyone. Today also you can talk and ask the question. So we started the grade 10 class today. Now the students are talking to me, right, everyone. So I expect from you also talk and clarify your issues, because when you have issues, how to solve? This is your class, right? So that's the basic feature of my class. And further, month a time, I arrange a very short question series, and I will give you to write the answer at the class time itself. Then you have to answer that, and then I will give the feedback individually, right? So we will work hard to join with us and learn precisely the subject content. Right. Now we will move to the first lesson of the grade 11. right. එහෙනම් සුබ මොහොතින් අපි පටන් ගමු grade 11 තමන්ගේ අවුරුද්ද හොඳ පාඩමක් ඒක අපි බලමු. Right. So the first lesson, write down the topic. Real numbers. So the first lesson, real numbers that we are dealing. Right. Although this lesson apply in the very first lesson, right? Any major questions under the real numbers in exam? Do we have a separate question for real numbers in the exam? No, right? But in some lesson, the next lesson, the logarithm, we have a log question in the paper itself. But under the real number, no specific question from the real number. But that knowledge is important for all the math concepts, right? That is the conceptual lesson, the real numbers, right? Not exam oriented theme, but for understanding the maths, we require this real number concepts. So we have to understand what are the numbers. These terms, terminology is very important, right? Okay. Before move to the right, in mathematics, we have the number systems, right? We are using the Hindu Arabic number system. Apart from that, we have the Roman number system, right? The number system is born from very fast, right? The number concept were born, right? Before the number concept were born, they used what? What they used? They use, like, imagine this comes with, right, uh, farms, right? Imagine farms, right? They have cows, right? Imagine they have such kind of cows. Me cows line, no, me cows. So they didn't know how to count the cows, right? These are the cows, right? But they do not know how to count them. One, two, three, four. This number system were not there. Then imagine this is their farm, okay, right? They open this gate, right, at the morning time, and then the cows released to the outstation, and then at the evening times they come back to the right cage again. This is the comeback. Then they need to find, right, whether the released all the cows came back to the cage again at the evening. Imagine two, three cows left, and some may be stolen, the cows. Then how to find that one? No number systems were there. Then what they did, they got some stones, right? Small stones, right? They do not know the numbers. Okay, they take some stone pack. Okay, when one cow is left to the left the cave, this cave, the cage, they put back one stone. If one cow gone, one stone keeping there. Then another cow going there, another one stone keeping outside. If another cow gone, keeping outside of this box, right? Okay, then if all the cows gone, the whole the box is empty. Next, once they came back into the cage, right, they put one cow coming, they put one stone to the box, another cow coming, one stone to the box, another cow coming, one stone to the box. Now if any stone is remained after the night, then they can think that one stone remain means one stone like a cow. They see that one cow is missing. If two stone is left not in the box, they think that these two stones mean, they do not know the number wise, but they know that this much of cows been missing. So that is how the number systems were there in previous history, right? Before it born. That's how they use these numbers, right? මෙහෙම තමයි ඇත්තටම උනේ. ඕක තමයි history එක number system එකේ. Right. Then, but later on, the people introduced the number system, then that would be very easy, right? They count how many cows inside now, then how many cows came back now. This is how actually happened previously, okay? So now we are using Hindu Arabic number system, right? Starting like the digits, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have only these 10 digits only in the number system. So using these 10 digits, we are doing all the games, all the maths games, only the right players here, right? Using these 10 players, we are handling all the maths, right? So in Hindu-Arabic system, these are the numbers. But in the Roman number system, we have a separate number system, but we are not much using in our mathematics syllabuses the Roman numbers. Okay, fine. Then we will write down the subtopic. So this is the idea, how it born and how it happens. Now we will check the number system. The first one we will write down, right? Subtopic, integers, right? Subtopic, write down integers. Some students still do not know the idea about integers. Integers, right? Integers, what is the symbol they are using, right? Remember this symbol. This is the symbol we are using for integers, Z, and here one line is drawn in this middle of the Z line. So this is the symbol of integers, Z. Right. So what are the integers? Right. This is the symbol of integers, Z. So what is the integers mean to you? Simply, integers means whole numbers. What is the meaning? Integer means whole numbers, full value numbers like 1, 2, 3, 4, 5, 6, 7, 8, and 0 also an integer, and then negative numbers also integers like -1, -2, -3, -4. These are also integers, right? So integer set is I define as Z, right? Here this is the symbol, and equal mark as a set I write. So it run through the negative infinity like -4, right? And here it continue. So here we have the end running further this sides, but I start now -4, -3, -2, -1. So this is the negative running and it moving forward here, right? That three dot indicated, right, moving forward, right, means there are a lot of whole numbers we have. Then we have the 0. So 0 is also an integer. Then we have the positive integer 1, 2, 3, 4, and it is continuing further. You put three dots. So this is how you indicate the Z. So idea is what? Z. Integer is a positive, integer is a whole number, either positive or negative and including 0. Okay, so integer includes negative whole numbers, positive whole numbers, and the 0, right? So then I have a subtopic, right? Positive integers. See there, this is positive integers. Don't write yet. Positive integers means the symbol we have Z and positive indicate with, here you write positive sign. Z plus on the top. That indicates the positive integer. If you see the symbol Z for integers, Z plus mean positive integers. So positive integers are defined, right? Just the positive numbers, positive whole numbers. So what is the positive whole number? 1, 2, 3, 4, 5, right? Three dots. So, right, these are the positive whole numbers. Okay. Now what about the 0? 0 doesn't include as a positive whole number. Remember that 0 is neither positive nor negative. So 0 is an integer, but we cannot say it is a positive integer. We cannot say it negative integer, but it is an integer. right? Like base and acid, right? Some are base, some are acid, but some are not either base, no, or the acid, right? Not belongs to both, right? In science. Then we have the negative integers, right? So what is, because when you are dealing the inequality lesson, they will ask to give the negative integer solution, positive integer solution. Then you should have this knowledge to identify integer. What is an integer? So negative integers, the symbol is, right, Z, and here negative. Okay, then you write Z and here negative sign equal. So how to indicate it? Z and you put negative sign there. So what are the negative integers there? You have negative three dots there. Right. I start with -5, -4, -3, -2, -1. Okay. Right. So this is the negative integer set. The specialty 0 is not belongs to here or here. It cannot be considered as negative or positive integer, but it is a integer. The general name belongs to that. Okay, fine. Right. Now you can write it down. If any questions, you can ask. The mics are switched on, right? You can ask any question. Okay, right. Write on this note. Right. Once you completed, raise your hand. Right. Okay, fine. So now you know what is the integers and right, positive integer and negative integer. Right. In the exam, if they ask to give the answer from the solution, mention the positive integer solution, negative integer solution, and they mention the integer solution. Zero includes integer wording. Zero include, but positive, negative, that wording doesn't include the integer. Okay, fine. Right now, we will move to the next part. So the integer is done, positive integer, negative integer, that is done. Then write down the natural numbers, natural numbers. Right, natural numbers start with n, then you put this symbol as n, and here we put this two lines on this n. So that is the natural numbers in the number system. Right. Right. Natural numbers. Natural. Natural කියන්නේ මොකක්ද? ස්වභාවික numbers ද නෑ. Natural. Natural numbers means, right, if we ask, right, there is a child in your home, right, we ask, count puta, puta count, or nangi count, mali count, count the numbers. So where they start? To count the numbers, where they start, the small child is starting count the numbers like 0, 1, 2, 3, 4, 5. Or if you ask somebody to count the numbers, they will start 1, 2, 3, 4, 5, 6. So they will not start with 0, right? Oh, so the natural number system means the positive whole numbers. It contains the positive whole number, like we call the counting number, similar to. So positive whole number set 1, 2, 3, 4, 5, 6, right? And it's continuing further. That is why we need to put three dots. If you do not put three dots, that means wrong. Why? Then the persons who look into that think that only 1 to 6 are the natural numbers, that ending. But three dot means it's continuing further. So these are called the natural numbers. So what is the specialty here? Zero doesn't include, but there was an argument in history with the mathematician. Some mathematician believe that for natural numbers that zero should contain includes for their regions, right? They inserted zero to the natural numbers, but some mathematicians reject the zero from the natural numbers and they started 1 to 6. Then what to do by ourselves? Right, but the majority people believe now that the zero doesn't include, and they start from 1 to the positive whole number set, that is the natural number indication, right? So you can write down this is the natural numbers, right? දැන් ඔය මැත්ස් වල ප්‍රශ්න ආවා ඒ කාලේ. රයිට් මැතමැටිෂියන්ලා මේව හොයාගන්නදී සමහරු කිව්වා 0 දාන්න ඕන කියලා සමහරු බිලීව් කරා 0 එන්නේ නැහැ කියලා නැචරල් නම්බර්ස් වලට. ඒත් තවමත් සමහර රටවල් වල මැත්ස් වල රයිට් එයාලා පාවිච්චි කරනවා මේකට 0 ඉන්ක්ලූඩ් කරලා. ඒත් සමහර පොත්පත්වල ඔයාලා කියවන්න එපා නේද පොත්පත්. When you read some books, you can find out that zero includes, but sometimes zero doesn't include. But in our level, our exams, we write natural numbers starting from 1. Okay, right. Now we learned that the natural numbers, what is the natural number means to you. Okay. Right. Now the very important part, this is the first lesson of the A-level combined maths, the rational numbers, right? The rational numbers. If you do the combined maths, the mathematics stream for your advanced level, you start the lesson, these numbers. Okay, there you learn that the rational numbers. Right. Now we will write down the topic rational numbers. Rational numbers. This is the very important thing you haven't learned previously. Rational numbers, the symbol we use is that Q. This is the symbol Q, right? And this like a double line between the left side of the Q. Q. Q is the symbol for rational numbers. Right. Now rational number මේක අඳුර ගන්න මේක තමයි ගොඩක් අයට අපහසු බැරි definition එක. So rational number is a number. So this is the definition. Rational number is a number equal, right, a number that to be denoted as a fraction mode. So if it is a rational number, that to be denoted as a fraction mode. Under which fraction mode, like division, like denominator is a and numerator is a, denominator is b. So the fractional number should be able to represent as a fraction mode. This is a fraction mode, numerator and the denominator. Where these numerator and denominator, you put two dots such that this a and b, a comma b, both a and b to be the integer numbers. That indication is an element of integer set. Integer set is z. Okay, a comma b is an element of integer set. And there is another requirement, and b not to be equal 0. B not equal. This is how you write B not equal to 0. And I will explain, don't worry. This is the definition of the rational numbers. I will explain one by one now. Now, what is this idea? The rational number should be as a fraction mode, as a fraction. And in this fraction, both numerator, denominator shall be an integer. So what is the integer means? A positive or negative whole number. Whole number. Positive or negative. That Z symbol. They are not Z plus or Z minus. And here B not equal to 0. Why this condition? B is what? B is the denominator of a fraction. Then my argument, what happened when the denominator of a fraction becomes 0? Why it, that logic given that B equal not to 0? When what is the answer of this one? බලන්න මේකේ answer එක දාන්න හැමෝම 3 divided by 0. What is the answer in maths? Okay, some are saying 0. 3 divided by 0. What is the answer? If you have a calculator with you, you can even apply 3 divided by 0. What is the answer? 5 divided by 0. 2 divided by 0. What is the answer given? What about others? Most are saying 0. It's 0. Imagine if you have a calculator with you, right? Apply that answer, take the answer. What happened? Is that say 0? It's not divisible. 3 divided by 0. Not divisible. What the calculator says if we have a calculator? Error. Some calculator says math error. So I have a scientific calculator. I will apply it. See there. Right. 3 divided by 0. Right. You can see here the calculator. This is our calculator. Right. Then I enter equal. See there. What's the answer says? That is math error. Math error. Are there such kind of errors in maths? Yes. So we cannot divide any number by 0. What that actually it cannot be defined. The answer is here cannot define. Can't define. We cannot define the value. So in a fraction, the denominator never becomes 0. Then the way you cannot take a value, that kind of number cannot define. But not 0. 0 comes here. If 0 divided by 3, that is 0. Here 0 answer. But when the denominator comes 0, that value not to be defined in maths. If somebody asks what is the 5 divided by 0, then answer should be it cannot define. That is error. Error means you not tell that is error. You tell that can't define in maths. maths වල එක define කරන්න බෑ උත්තරේ. ගන්න බෑ උත්තරයක්. හොඳට මතක තියාගන්න ඕක කහලා බලන්නකෝ ගොඩක් දෙනෙක් what is the answer කියලා කියන්නේ 0 නැත්තම් වෙන උත්තරයක්. So in maths it can't define. That's why they mention in this argument, right, denominator cannot equal 0. Remember why there? ළමයි ඔක ලියනවා නිකන් ගිරව් වගේ ඇයි දන්නේ ඒක ලියන්නේ. ඒක ලියන්නේ උත්තරේ ගන්න බෑ මෙයා 0 වුණොත් in a fraction. Okay? Right. So that is the definition of the real numbers, rational numbers. Then I will take you to determine whether a given number is a rational or not. The rational opposition is irrational numbers. If a number cannot indicate by these values, this method as a fraction mode, and then these are not the integers, then that comes to the irrational number. Opposite of the rational number is irrational numbers. Okay, write down this definition. Yes, in some calculator says can't divide by 0. It says like in this wording, can't decide by divide by 0. I think that wording is not there. Either o, mathero, whatever. I think modern calculators sometimes say that can't divide by zero. Okay, write down that's the definition. Right. We will see the Tarus's calculators. Yes, can't divide by zero. Yes, I think that mobile application, right? Okay, fine. So now we know the definition of this one, especially right. It cannot be zero. The denominator cannot be zero. So now I am asking, but if I tell that one, I know that you are not understanding what is actually rational number. Then what would be the rational numbers? Examples for rational numbers. Tell me. I am asking first one. Select the rational numbers here, right? I'm asking, this is my question. Confirm whether two-third is a rational number or not. This is my question. Confirm whether two-third is a rational number or not. So here three tests to be passed to become a rational number. What are the three sets? Three tests. First one, it shall be indicated as A upon B. And the second test, A and B both should be integers. And the third test, the denominator not to equal 0. Then check whether three tests been satisfied here. Now you check, right, 2 upon 3. Now you write here denominate numerator like A and denominator like B. Okay. Now you write A equal to and B equal 3. Okay, then you can say that yes, A and B, A comma B, 2 and 3 are the integers. Yes, that is okay. Integers A2, B3. Then both are integers. Okay, then their next condition is to check the denominator. B is the denominator. No, B not equal to 0. Yes, 3 is there. Now you write B equal 3 and that is not equal to 0. 3 is not the 0. That's the language, math language. Understood? Then it is a fraction mode. Then both are integers, yes, and then denominator not equal to 0. All three conditions satisfied. Therefore, we can say that, therefore, two-third is a rational number. Okay? Is a rational number. Satisfying all the three conditions. Okay. Write down it. Example. If any doubt, ask. Okay, I will explain it again. Okay, sure. Then I will again with another new example. So those who completed mathematics exams, so what about your marks? If you got the marks, right, send me the marks of third term. I think, yes. Or if you have the exam, what about the exam? Tell me, send me a message. What was that? Is it hard or easy or you gain something rather than the previous terms? So here, scoring 75 marks is a big achievement in grade 10. Right? Because it's a good achievement, but we have to increase that. Okay, Sweta, very good. Ah, geometry sums without geometry. Okay, 84 and 71, 61. Okay, 73. No problem. We can do it. We have the 1 year time period. We will enhance, sure. So I have shared a tutorial to you, right? The sharing tutorial is very bigger issues to my side, but for your sides, to have receiving a such duty is very advantage, right? You can deal with the questions within a week that are especially the advanced questions there, and past paper question also there from the term test and the provincial papers as well as the past papers. So every those who take the we will start the tute works by the next week. Some of you didn't take the tute set, but we will start after you got the tutorial works. Okay, right. That now it is a rational number, right? Then we show that confirm, right? Another example that some of you didn't understand it. Confirm whether, right, 1/10 is a rational number or not. Right. Now check how to determine this as a rational number or not. How you write the fraction 1 upon 10. Now what is A there? A is 1, B is 10. Now you write in the top part is the A, bottom part is the B, numerator, denominator. Yes. A equal 1 and B equal 10. Now you know that A and B are whole numbers. Then A comma B elements of integer set. Yes, that requirement fine. Fraction mode it can write. Fraction එකක් විදියට එයා ලියන්න පුළුවන්. And in the denominator numerator both are the integer values, and the second condition, the denominator not to be equal, so be equal 10, and that is not the zero, that's the identification. Okay, now therefore, it satisfies those three conditions, denominator, numerator writing method, then the both to be integers, and then denominator not the zero. That the three conditions satisfied, we show in that way. Therefore, we can say that 1 upon 10 is a rational number. Right. Okay. Write it down. I think now the sound is okay to you. We changed to a high quality microphone, and I think now the setup is okay, right? Okay, Tarsha. Yes, that right. So that is okay. Now I am asking, try to do this one. Now what is the conclusion? Here, two-third is a fraction, 1/10 is also a fraction. Now you can see that then all the fractions are rational numbers, right? All the fractions are rational number. In a fraction, we do not write a denominator zero, no. If we write a fraction with this way, that is not a rational number. But normally a fraction doesn't contain a zero. Then I am asking third one, 0 upon 2 is a rational number or not? Confirm that one. Rational number or not? Confirm it, prove it. This is some additional knowledge. What is your idea? 0 upon 2 is a rational number or not? Prove it. Very good. But understand, correctly understand. With the three test, apply to the three test. Okay. Right. Now check 0 upon 2. Now check the two test. Right. Here A, here B. Right. Then you know that A equals 0, comma, B equal 2. Are they integers or not? 0 is an integer, right? Understand the definition we learned. 0 is an integer, yes. Then A and B, A comma B are the integers, elements of integer set. That is okay. Then check the B, denominator. Denominator is what? That is 2. B equal to denominator. That not to be equal 0. न्यूमरेटर के इक्वल जीरो बने की नॉन रैशनल वाला एक प्रश्न में न्यूमरेटर can zero but denominator cannot zero, so then this is satisfied. B equal to 2 that not equal 0. If denominator 0 is the problem comes. Now then you can say that therefore uh, here 0 upon 2 is a rational number. So now you know then all the fractions are rational numbers. What is the conclusion? All the fractions are rational numbers. So below that, make a point, bullet point, and write, therefore, all the fractions are rational numbers. All the fractions are rational numbers. Right. Okay. Right. Then our question. Now I am asking. මේකට try කරලා උත්තරේ දෙන්න බලන්න. Confirm whether the number 5 is a rational number or not. So 5 is a rational number or not. Confirm with the method. What happened? In 5, 5 is a whole number. So can't we write it as a fraction? We can. What is the denominator there? Denominator is 1 of a whole number. Denominator එක මොකක්ද වෙන්නේ? 1 වෙනවා හැමෝගෙම. Right. 5 can be written as 5 upon 1. Yes. In a whole number, there is a hidden denominator. Hidden denominator is there. That is 1. Okay. Now it is like here A, here B. Okay. Now you can say that A equal 5, B equal 1. Okay. Both are integers. Yes. Okay. Then further you check the denominator. Denominator is the b equal 1 and that is not equal to 0. Okay, then that is a rational number. So therefore you write 5 is a rational number. Now you can say that likewise 10, 20, 25. So these all are rational number. That means all the integers rational number. So if somebody asks 0 is a rational number or not, how to prove that? 0 can be written as this one. Denominator not equal 0. That's the major concern. These both are integers, yes. Then that is a rational number. Okay, right. Then all the integers, negative number is a rational number or not? If I ask negative 3 likewise, is that a rational number or not? I am asking. Now you can think and argue. Tell me negative 3. Is it rational or irrational? It's a rational number. Why? Negative 3 can be written as negative 3 upon 1. So that negative 3, negative integer, no problem. That says integer only. So it is integer and denominator not equal. So that is also a rational number. So now you can say that all the positive, negative integers are rational numbers. Therefore, you can write, therefore, all the integers, namely positive integer or negative integer, including 0, the wording, all the integers are rational numbers. Now you know somebody asks, what are the rational numbers? All the fractions are rational numbers. All the integers are also rational numbers. Right. 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 Okay. Now it is fine. Now you understood the rational numbers. Right. Now we will move to the irrational numbers, the opposition of it. Irrational numbers. Irrational. Irrational numbers that is indicated by Q dash. Right. Irrational number like Q dash. Q dash means complement of Q set. If we take a certain set like Q, then you can understand the elements. This is the set. Okay, imagine we have the rational number set is this one. This is the rational. We call the Q rational numbers. And then except that outer region, right? This region is the irrational number, right? This is the irrational. The green color is the irrational, what we call the Q dash. So this is the Q dash. Okay, except rational numbers, everything irrational, right? So what are the irrational numbers? Normally, I will tell you, right, irrational numbers, they are cannot to be written as a fraction mode, right? They cannot to be written as a fraction mode, right? They cannot to be indicated on a number line, right? So it cannot be indicated as a fraction and they cannot to be indicated as a fraction mode. So then what are these numbers? The irrational numbers are mostly the surds. What are the surds? Surds means square root values. Square root 2, then square root 3, then square root 5, right? Square root 7, right? Square root 10, right? These are called the surds, right? This cannot to be written as a fraction. Surds. We call these are the surds. So why they can't write? So now you argue why it came as irrational. Then you try answers. We know that here denominator 1 is there no. Then it is a fraction mode no. Why then it cannot write as a fraction? Yes, fraction mode fine. Now it is B, it is A. Now that is fine. B is 1. But what happened? The A is a square root 2. Is this integer? Square root 2 is an integer or not? Not. Although 2 integer, square root 2 is not integer. So that fails at that condition because this value is not an integer. That's why it failed and denominator not equal 0. That is okay. The second condition, both to be integers, but the numerator is not an integer. So that fails. Okay. Then further, you can see that why I skipped the square root 4. Square root 4 I skipped. Why? Square root 4 having exact answer. What is the exact answer? That is 2. So 2 is a whole number. It satisfies the rational number conditions. Then square root 4 is a rational number. Why? It having a perfect square. Answer is there. It having an exact answer. But when you take root 2, so when you write the value of square root 2, then that is not ending, right? That continuing, right, unlimitedly, right? 1.41421356, right, continuing further. Okay, so we cannot write it as a fraction. So it's continuing further without any pattern, right? We call the not ending decimal here. Then square root 3 also, if you get the answer of square root 3, that is also continuing further 1.7320508082 and continuing further. So now you have an idea. But when you take square root 9, what happened? It is exactly 3. So it can be written as a fraction, 3 upon 1. Then that is a rational number, not irrational. So then tell me, what are the examples for irrational number? Irrational number is any surds. Any surds can take except the perfect squares. What are the perfect squares? Like 1, 4, 9, these are the perfect square, having the square root values 25. Except these values, the other all the values are the not the irrational numbers. The except other all the value except this perfect square are irrational numbers, irrational. So in simply remember surds, this square root values except the perfect squares, right, all are irrational numbers. And 5 also irrational number, 5 in maths. So some students say that, so 5 equal 22 upon 7, no. Then it's rational, no. Why? 7 denominator, 22 numerator. Right. Then these are integers. And even the 7 not equal to the 0. Then why you are saying that irrational number? Why? The 5 is not exactly equal to 22 upon 7. That is an approximate value. We cannot write it as a fraction there. For math simplification, we use as a fraction only. So in Babylonian maths, they use as 5 upon 8. In Babylonian maths, a different fraction. But in our maths, we are using 22 upon 7. Some are using some other fraction mode. So this is not an exact value. They assume a approximate value. So if you write to the 5 is 5 to the decimal places, you know that it can be if you write 5 into the decimal places, that can be written to the more than 61.8 trillion decimals. If you write the 5 values to the decimal places, it continues more than 61.8 trillion decimal places. Okay, right. So no any pattern of 5. So it is continuing 3.14, right? Likewise, it is continuing without any ending or without any pattern. So you know that March 14 is the 5-day, World 5-day. Okay, World 5-day, right? Why 3.14? So that is a stand that's established in the world, right? So this is the 5, that is also a irrational number. Understand? Right. So now root 4 equal to, then this is not an irrational, that is rational. So understand here, additional knowledge, right? That is rational number. Root 4 rational number, but all are irrational numbers. So these are irrational. So write down these things, irrational. Irrational numbers. So here also the surds irrational numbers. එහෙනම් කවුරු හරි ඇහුවොත් if somebody asks what are the irrational numbers, take that square root value, square root 2, square root 3, square root 5, 7, but not square root 9, not square root 16, not square root 25. They have the specific values. The whole number answer is there. That's why I showed that that is a rational number. Yes, ask question. Yes, all thirds are always irrational except what? Not all, except that perfect square given exact square root values. Except that one, all thirds are irrational numbers. So what do you can exclude? Square root 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, likewise continuing perfect squares, or except all that perfect squares square root, other all comes as the irrational numbers. Irrational. So example, these and here especially write the 5. 5 is also an irrational number. Square root 6 is there. I forgot it. That is taken now. Square root 6 there. That is also irrational number. Exclude only 4. 4, 9, these things. Yes, hi, right. You want to finish, raise your hand. So all the thirds are irrational except now you can write down below. All the thirds are irrational except the thirds of perfect squares. All the thirds are irrational numbers except the thirds of perfect squares. Perfect squares කියන්නේ අර අපි කිව්වේ examples මේවා ගන්න බෑ. Root 4, root 9, root 16, these are rational. Root 25, 3 dots. They are rational කියලා පැහැදිලිව පේනවනේ, right? Why? They are having a specific answer, then that can be written as a whole number. Right. Did you finish writing? Okay. පැහැදිලි නේද ළමයි ටිකට? Right. Now it is fine. You understood what is a rational number, irrational number. Right. Now, on අවසානම topic එක මේ number වර්ගවල නැත්තම් පැටලෙනවා. Now the real numbers, right? Real numbers. The topic write down real numbers. Real numbers indication is capital R and two lines there. බලන්න lines දෙකක් තියෙනවා R එකේ මුල. Real numbers that start with R. Right. On make lazy. Right. The rational numbers, the real numbers are the sum of real numbers are the sum of rational numbers and the irrational numbers. Right. How to indicate in a nice way in a symbol? Rational number is R, plus means the union. Sorry. Rational number Q. Real numbers no R. Right. Rational number is Q. So rational real numbers are R equal, right? The set of rational numbers plus means the union, irrational numbers. මේ දෙකේ එකතුවට අපි කියනවා මොනවද? Real numbers. තේරුණාද? What is the real numbers in definition? That is the sum of rational numbers and irrational numbers. Sum indicated by the union. So the real numbers are the set of both rational and irrational numbers. Okay, so the real numbers are the set of both rational and irrational numbers. හරි. එතකොට එහෙනම් number system එකේ වෙනත් numbers තියෙනවද මීටත් අමතරව? Real number කිව්වම දැන් බලන්න rational කිව්වම rational means all fractions, all decimals, and then the what we call the whole numbers, integers comes. Irrational mean all the surds come in. Then except rational, irrational, the sum is the real numbers. Any numbers other than the real numbers in maths? Yes. We have the real numbers. Other than that, we have that called the imaginary numbers. If you do A-level maths, you learn that imaginary numbers. Okay, what are the imaginary numbers? If you take this value for your knowledge, no need that one. Negative square root values. If you have the calculator, apply -1 square root, then that doesn't give the answer. Square root -1, that is imaginary number. If you have the scientific calculator, that gives as I. Make the symbol like I කියලා. Right, if you have a scientific calculator, you can check, that gives you I. So these are called the imaginary numbers. එහෙනම් මේ ලෝකේ number system එකේ වර්ග දෙකයි පුතා. Real numbers, the other one the imaginary numbers. Real numbers වල වර්ග ගොඩක් subsets තියෙනවා. Subset are the decimals, the fractions, the integers, everything. The third are the other irrational numbers. Okay, right. So that is not needed, this one at this level. But remember, Other than real numbers, we have that are called the imaginary numbers. We will draw a diagram now after this. Okay, complete this one. Okay, now I draw a Venn diagram. See that identifying this all the number categories. Right, right. Okay, now you know that real number is the sum of rational and irrational numbers. Right, now check. Okay, up to now we discussed about the numbers types. Now we are moving to the decimals. Write down the topic, decimals. The Dahagana decimals. Right. Okay. Decimals. What type of decimals we have? Whenever these are the decimal types. Okay. Some decimals are there, right? Like I will take first example 1.2, right? 0.52, 0.1235, and it is having an end. Okay, end, right? There is an end, right? And that is not recurring, right? Continue වෙන්නේ නැහැ එතනින් ඉවරයි, right? The මේ type එකට අපි කියනවා the end decimal, the terminating decimal. Sometimes there is a terminate. Oh, right. So what is that name for that one? The finite decimal or the terminating decimal. Right. So this is called the finite decimal or terminating decimal. But some decimals are there like that one decimal place is continuing, right? Not ending. It is continuing. Or sometimes two decimal places continuing 5 3 5 3 5 3, not ending, right? So this kind of decimals are mentioned as the recurring decimal. Recurring decimal. Recurring කියන්නේ නැවත නැවත යෙදෙනවා. Recurring decimals. So the second type is recurring decimal. Okay. Understood? So what are the two types here? Finite decimal means the terminating decimals, right, have an end, right? Not further divisible, just finished. But recurring decimal means a set is one decimal place or set of decimal place is repeating forward, right? Repeating further. That is called the recurring decimals. And then we have some, right, infinite decimals like that belongs to the irrational numbers. What are the irrational number? Like root 2. If you take root 2 like 1 point, you got that root 4 2 value. That is 1.41. No any pattern and no any pattern, and it's continuing further. So it cannot be represented as a fraction. So then like root 3, that is irrational number, the infinite decimal, the 5 also infinite decimal. So these are the infinite decimals. So now you can see that what are the types of decimals you have. The finite decimals, right? We have a specific n, then recurring decimals like one decimal place or several decimal places are continuing. The other one is the infinite decimals. Right. Write down this decimal categorization: finite decimal, infinite decimal, and recurring decimal. Recurring. Yes, finite decimal means Pota. Finite means like I will take the fraction mode and explain. So you can write down. If I take like 1 upon 2 fraction, then when you convert this fraction to decimal, how to do that one? Just you divide 1 by 2 in the long division. See there, for 1 0, then 1 remaining, put decimal point and you bring 10. For 10, you have 5. So that's ending, right? 0.5, then what is that type of decimal? That is finite. Finite කියන්නේ ඉවරයක් තියෙනවා. Ending. 0.5 is a finite decimal. But now imagine you take, this is the example, you take 1 upon 3 fraction and you make it as decimal. How 1 upon 3? Just take 1 and divide by 3. Then 3 0 0 1 remaining. For 10 you take 3 3 9. 3 3 9, 10 subtract 9 1 10 3 3 3, right? Continuing further, not ending. Okay, so that, but you can see that one decimal place is continuing. There is a pattern of continuing. What is the difference between recurring and infinite? Here also not ending, but here there is a pattern and there is a repetition. You can identify it, and further it can convert as a fraction. All the recurring decimal can convert to a fraction, but all these infinite decimal cannot convert to a fraction. So now you can have an idea. Finite decimal and recurrent decimals are rational numbers, but infinite decimals are irrational numbers. Why? These two convert to a fraction. Here 0.5 in 1 half. Here, while 0.333 means one third. One third is a rational number. But here, these are the irrational numbers. Further, you can make a note. These are irrational numbers, and recurring decimals and the finite decimals are the rational numbers. These two comes as a rational numbers. Okay, write down. Okay, right. Note it down. උදේට ක්ලියර් කරගන්න පුතා. ඕන ඩවුට් එකක් අහන්න. So what are the three types of decimals? Finite decimal, recurring decimal, infinite decimal. Finite decimals can convert as a fraction. Infinite recurring decimals also can convert as a fraction, and infinite decimal cannot convert as a fraction. They are absurds. So they are irrational number. These both comes under the rational numbers. So this chart indicates all the things. And you know that how to indicate this recurring decimal in nice way. කොහොමද recurring decimal එක indicate කරන්නේ? මොන මම කියලා දෙන්නම්. ඒක maths වල indicate කරන විදිය. Right. So 1.222 recurring. So this is how you indicate this one. You write 1.2, 2 is repeating. You write on the top a small dot. On the two top, you make a small dot, not a zero, just dot, bold dot. Right. So that means 1 point, right? 2 is recurring. So here 5, 3 recurring, then how to indicate this one? You indicate 0.53 recurring. So you put a dot on these both two, that indicates 5, 3, 5, 3, 5, 3. Likewise, recurring happens. Right, write that indication of these recurring decimals. Okay, fine. Now tell me, then make a note. All the finite decimals and recurring decimals are, what are they? Are rational numbers, but all the infinite decimals are irrational numbers. Make a note at the bottom. All, write down, all the finite decimals and recurring decimals are rational numbers, but the infinite decimal, sorry, if yes, infinite decimals are irrational numbers. Okay, fine. Right. පොඩි වෙලාවක්වත් කට් කරගන්න එපා sessions live sessions හැමෝම live session වලට එන්න ඕනේ දැන් 11 ඉන්නේ මොන හේතුවක්වත් නිසා මේක කට් කරගන්න එපා live session එකකදී තමයි හරියට ඉගෙන ගන්න පුළුවන් හැමෝම මේ session එකට එන්න ප්‍රශ්න අහන්න ක්ලියර් කරගන්න ඕන ගැටලුවක් මැත්ස් වල ගේන්න ඩුමානි ගුරුවරයාට පුළුවන්ද කියලාත් බලන්න එපා මැත්ස් නේ ඒ නිසා එහෙම හරි කමන්නේ ප්‍රශ්න අහන්න එතකොට මම ප්‍රශ්න අහනවට බයින්නේ ඕන කෙනෙක්ට ඒ වෙලෙම උත්තරේ දෙනවා. දන්නේ නැති දෙයක් තියෙන්නත් පුළුවන් මම දන්නේ නැති දෙයක්. නමුත් almost I can answer the any questions of maths. Right. ඒ confidence එක ඔයාලත් තියාගන්න. Right. So now it is fine, finite decimal, recurring decimal, infinite decimals. Right. Now okay, fine. Now I conclude by a chart. බලන්න මේ diagram එක තුලින් ඔයාට අඳුර ගන්න පුළුවන් අද කතා කරපු totalම lesson එක. Right. මාත් එක්ක අඳුම් වෙන් diagram එක. Right. Now tell me, right, what is the bigger set contain? වැඩිම set එකට අයිති වෙන්නේ මොන numbersද? ලොක්කා කවුද මේ number system එකේ කියන්න බලන්න who is the captain of this number system leader එයා යටතේ තමයි අනිත් ඒවා who is the leader of this number system that we discussed today send me the answers who is the leader what do you think lead is what lead ලොක්කා කවුද එයාගේ යටතේ තමයි අනිත් ඔක්කොම ඉන්නේ lead is the real numbers lead is the real numbers not integers. Integer is a subset, part only. Integer comes under what? Real numbers. So the bigger one, bigger is the right. බලන්න මේ diagram එක මම පැහැදිලිව explain කරනවා. So I write this is the universal set. So what is there with the symbol? This is real. Okay, real numbers. R. Okay, inside that I draw 3 circles there. Okay, right? Now with the understanding, right? Then මට කියන්න real numbers. Then this bigger one, this set is denoted this as, right? So this is denoted as, right, these 3. Okay. And then, right. Now check with me. Right. I mentioned under the real numbers, major one is the rational number. So the rational number indication is Q, right, Q. Then Q is this one. Then where are the irrational numbers? ලොකුම කෙනා rational, irrational කියන්නේ නම් මේක ඇතුළට වැටෙන්න බෑනේ. rational ට ඇතුළට වැටෙන්න බෑ. Except rational, everything irrational. So Q dash is the outside set. So this is the Q dash. Right. But now you can see that Q plus Q dash is the rational. හරිනේ. Q කියන්නේ මේ set එක රවුමම ලොකුම රවුම ලොකුම set එක Q plus outside is the Q dash irrational is the rational number. Understand? Right. Rational plus irrational is real. Real are real, right? Okay. Now under the rational number. So what are the irrational numbers? Examples. Irrationals තමයි නිකන් examples ප්‍රමාණය අඩු වෙන්නේ හිටියේ. කවුද? irrational වලට තමයි අඩුම උත්තර කියන්නේ ප්‍රමාණයෙන් අඩු කියන්න බෑ අපිට. මොකද root ගත්තාම number system එකේ perfect squares ටික ඇරුණාම except perfect square all other surds are irrational. But type එක අඩුයි. කියන්නේ surds විතරයි ගන්නෙ. එහෙනම් what are the example for Q dash? I write Q dash like root 2, root 3, right? Then root 5. Okay, then I write 5. Right, these are the rational numbers. Examples, it comes to the outside of the rational numbers, but they are under the universal set real numbers. Okay, right. Then under the rational numbers, I can make a subset here called Z. අපි කියවනේ ඔක්කොම Z's mean integers are rational numbers. Okay, fine. Under the rational, it is a subset of Z. හරිනේ. ඒතර Z ගේ තව subset එකක් ගන්න පුළුවන්. Z කියන්නේ all the integers. Then ඒකේ මම වෙනම එකක් ගන්නවා positive integers. So from the integers, positive integer is a subset of integer. හරි. එහෙනම් ඔන්න බලන්න දැන්. එතකොට rational එකට වැටුණා මේ set එකට යන්නේ ඔක්කොම integers, whole numbers. Z එක ඇතුලේ. එතකොට whole numbers ඇරුණාම except whole numbers, what are the rational numbers? All the fractions, all the decimals. So I can apply here fractions. 1/3 is a rational number, but outside of the integer set. Fraction is there and decimal 0.5. Okay, and recurring decimal 0.222. Right. That is also rational number, but that is not an integer. That's why outside the integer, but inside the rational number set. If any doubts, ask. Right, examples given, and then Z there under the Z, right? Here the Z plus. So Z plus there means what? Positive integer only. I write example 1, 5, 10 positive integers. Then positive integer except positive but integers. What are the except positive integer integers? The negative integer comes as well as -5, -3, 0 also there. Okay, so now you can have this answer clearly about the rational numbers, real number. Hands up those who understand this chart. Hold the lesson, indicate by this chart. Right, I will again explain. You can draw it nicely. I will again explain. Now everyone see there. Right, the bigger universal set is the real numbers we indicated by R. Under that two subset, they are majorly rational and irrational. Rational is Q, irrational is Q dash. Right, so the irrational number is thirds and 5. That is okay. That is why it's outside of the Q. So inside Q we have the Z, and then we have the Z plus, and then Z is the integers, Z plus is the positive integer. Sometimes this Z plus is indicated as, we can indicate as N by natural numbers also. Same to the Z plus, right? So now under the Z set, you can see 0, positive integer, negative integer. But here we subset to a positive integer. Here positive integer only. Then it comes to the outside, the negative integer and 0. But all are under the Z set, integer set. Okay, write down it nicely. Right, complete it. Right. Right, බලන්න අද කතා කරා ලොකු පොඩි lesson එකක් වුණාට although it's appear as a small lesson but different concepts are there. So those who got the tudes, right, they can start up with these basic concepts. Like they in the tutorial they have asked like what are the rational numbers, irrational numbers, natural numbers, integers. So except the third part, so today I conclude all the number systems, number category, the decimal number, and especially how to determine a given number as a rational number or not. Rational number is very important. This one, right, with the definition, right. Again, I write the definition of rational number, right. A upon B, right, and A comma B are the integers, and further B not equal to 0, right. So this is the definition of rational numbers. Okay, right. We totally discuss about that lesson part today. So we have only the balanced part is the surds. Right, third simplification that is important in maths. In future, we have to use that third simplification. So we can deal with by next week. So you all can arrange the tute for you, and then we can work with the tute for this week. But for this week, we have very limited works to do. Just started the grade 11 only. After, so next week I will completely finish the lesson number 1 by next week. Right. Okay, Putta. So I will conclude the session for today. Right. Thank you very much. So we will meet by the paper and the theory classes as the timetable given to you. Right. So I will start the revise and rise after this class at 10 p.m. Those who join with that also can join with the revise and rise. Okay. Thank you very much. Have a nice day. We'll meet by next week.